Hi, this is Team Alissa, and this is our presentation on energy demand forecasting. This is the data preparation. The first step, we we uh, we did some data cleaning, and then the second step, we provided the descriptive statistics, and the third step, we normalize using the median of 29700 and the standard deviation of 11600. The next step is to determine the persistence, which we use a factor of 5 and arrive at our persistence value of 0.118. This is a number to beat. Okay, next we focus on windowing, and this will enable us to improve the learning. We use a mean of t minus 5 to t plus 0. Same for the standard deviation, and the difference of t minus 20 to t plus 0.
With our neural network, we decided to have 4 layers with successive shrinking of 1/2. The neural network sizes are 2, 4, and 8 respectively for layers 1, 2, and 3, and we have opted to use ReLU. The network type that we have chosen to go for is the difference network as opposed to the naive network. For model solver, we have opted to go with Adam. Adam, while not as fast as stochastics, provides better solution, so that is the reason behind our choice. We have opted for an early stop of 25 and skips of 20. Our configuration is as follows. We've got 0.5, 0.1, and 0.25 for dropout probabilities. We've got 32, 64, and 128 for neural network size. Our input size is 20, and we've opted to go for 10,000 iterations. As earlier mentioned, our solver type is Adam. However, we would like to point out that ideally we would like to have 5 repeats for every single configuration. This was not executed because the system was highly loaded. Apologies. But in a best case scenario, that's what we would have done. As for training and test losses, the training and test loss decline sharply early in the model, which is a good outlook, especially because they are already lower than the persistence of 0.118, the target that we want to beat. From our multiple configurations, the one which returns the best result is configuration number 8, the test loss of about 0.009. It comfortably beats the persistence of 0.118, and we are quite satisfied with it. We took a look at the training predictions and the test predictions graph. There is good overlapping between the actual and predicted values of both training and test. Next up, we also observed the scatter plots for actual versus training predictions and actual versus test predictions. We see that there is a good forecast. The scatter lies around a straight line. It is quite clear. Okay, to attempt to identify the lagged correlations, it seems that our training and test graph peak at near 0, which is quite ideal. With that, we have come to the end of our presentation. There are some possible improvements that we would like to make if we had some more time or some more expertise, which will be to include more repeats. Earlier we have stated that we wanted to have at least 5 repeats. We also want to have more regular, we also want to implement regularization if we are able to. Thank you very much for the mentorship so far. Signing out, Team Alissa.